So here are some examples of forecasts. And when you're talking about examples, you need to look at data being a time series data. Time series data is demand data recorded over uh, regular time intervals, and we want to predict. Now there are many different levels at which we may do forecasting, and here let's look at some of the examples here. Suppose if we are talking about on a gross level US monthly retail sales and food services, okay, measured in millions of dollars. So this is the actual sales. So over the years, and you see a seasonal pattern, and we want to extend it into the future, yeah, and try to forecast in the future. So that's one level of forecasting. And we can also look at just the seasonal variations, seasonal ups and downs. How much is it going up during the high season? So like 25% more than the average, or how much does it go down during the low season? So you may want to predict what these seasonal variations are, seasonal factors. So that's something that you may want to forecast. Or if you deseasonalized, okay, take the actual data and remove all the seasonality, then you see purely the trend here. All the seasonal variations have been stripped out, and you want to forecast this seasonal a time series that is devoid of all seasonality. So here is another example of percentage change year after year. Okay, and there may be some sudden changes in demand due to some unforeseen catastrophic incidences, like for example airline industry after 9/11 there was a sudden decrease in airline traffic. So that is a catastrophic incident, and that may have an influence on how you forecast in the future. So here is another example of serious injuries and fatalities in UK roads, and again you see seasonal pattern. So this kind of plots are called time series plots, and we will look at examples of time series plots later. So here, we want to forecast the serious injuries plus fatalities in the future, and here is data that you can look at. Okay, another example of the same thing. Okay, here monthly US domestic air passenger mileage, and once again here you see the sudden drop, the September 2001 9/11 incident. So often when you see when you do a graph, when you see unexpected changes, and you usually put a notation there to explain the sudden dips and sudden increases. So here is another plot that's very useful in forecasting, and that is a scatter plot, where you have two numerical variables, and you put one numerical variable in x-axis and another numerical variable in the y-axis. So again, we will look at concrete examples of scatter plot in the next chapter. So your Major League Baseball, we want to try to estimate what the salary of baseball players will be based on the number of years the player has been in the major leagues. So here is a scatter plot, and you see there is a lot of unexplained variability here. So scatter plot shows you whether it is a good idea to show a linear relationship or a non-linear relationship in predicting or forecasting salary. So how to do forecast? And there are basically two different broad categories of methodologies. You have non-quantitative judgment methods, and then you have quantitative methods. So which of these two methodologies you will select depends upon whether we have sufficient quantitative data. If you don't have quantitative data, of course you would be restricted only to judgment methods. But if you do have quantitative data, then you would use quantitative methods. You may also supplement some of the judgment methods to correct or to fine-tune your quantitative forecast. If you have quantitative data, then what kind of methodology will you use? Will you use exponential smoothing or ARIMA methods, the so-called ARIMA methods, which you would use if all you have is the demand data? There is no other explanatory data to explain the demand. But if you have explanatory data, then you can use regression analysis in addition to the exponential smoothing. So here are some of the methodologies that you can select to do your forecasting. And here is a step-by-step. We have 7-step forecasting procedure where you define what is to be forecasted, what are the resources that are needed, you collect relevant data, you conduct your initial quantitative analysis, select an appropriate forecasting method. So after that, you use that forecasting method to generate forecasts and then evaluate. You keep evaluating as we go through the horizon, developing new forecasts. There are lots of computer packages that are available, and there are sophisticated packages like SAS, SAS, and SPSS. Okay. Minitab is not that commonly used in industry. It's used in Six Sigma operations, but SAS and SPSS are more common. Of course, we can also use pre-packaged software packages that are geared towards just forecasting methodology, whereas SAS and SPSS are generalized statistical packages that we can use for the purpose of forecasting. But of course, we have Excel. Excel can be used to develop forecasts, and that's what we will be using because everybody has access to Excel, whereas SAS and SPSS are very expensive software packages. So we will look at, if time permits, we will look at SAS a little bit, but most of the class will be using Excel to develop forecasts. And here are some of the sources where we can get data: census.gov site, BLS, the Bureau of Labor Statistics, and then in the UK, the National Statistics site, and similar sites are available for other countries where we can go and gather data. And there is industry-specific data that is available, and we have Lexis and Nexus, and we have lots of sources, public sources of data, and of course, internally for a given company, you'll have internal sources of data that we can use for forecasting. So the rest of the book is organized. First, in chapter 2, we'll look at some basic statistical tools that are needed for forecasting. Then 3 and 4, chapters 3 and 4 are trend and seasonal patterns, or what one would call as time series methods. And 5 and 6 are extensions of those time series methods, but these are called state space models or ARIMA models. Okay, we will look at these 2 chapters if time permits. But we'll look at 7, 8, and 9, which are regression-related models, so very important models. So we'll spend a lot of time on that. In chapter 10, 10 to 13 are more advanced topics. And if we have time, we'll get into that. Otherwise, probably not. So advanced methods and judgment methods and so on.